Chapter 3, Part 2 will begin by looking at higher order conditioning before examining some additional aspects of classical conditioning. To start, have you ever wondered if it's possible to become conditioned to an item that you've already been conditioned to? For example, could the dog who learned to salivate from the metronome then learn to salivate to another object that always appeared with the sound of the metronome? And the answer there is yes, and this is called higher order conditioning. So what if a new neutral stimulus is paired with a conditioned stimulus? In our example, the metronome that the dog has already been conditioned to associate with food is consistently paired with a black square. We call that CS2. It's the second conditioned stimulus. That nomenclature is important. Make sure you know that. The neutral stimulus in this situation becomes another or a new conditioned stimulus 2. This was first discovered by I always say his name wrong, Frolov. And what he learned was that the metronome after the metronome had become a well-established conditioned stimulus, and that's very important. You have to wait until CS1 has been established. He then held up a black square and activated the metronome, and the black square became another conditioned stimulus over time. This means that many more stimuli can come to elicit conditioned responses, and there isn't necessarily a cap to the number of conditioned stimuli you can have. We start with CS1 and it can go all the way to CS10, CS20, and so on and so forth. Interestingly enough, we know that word pairings are very likely to become conditioned stimuli, specifically higher order conditioned stimuli. Take a second, I'm going to show you a list of words and I'll read them out loud. What do you think of when you hear these words? Hot, pizza, mountain, school, Mrs. Stern, or now Dr. Stern. I need to change that. You have associations with words like these, but where do those associations come from? Many times, they come from higher order conditioning. Let's take the example of pizza for a second. You might associate pizza with feeling good or being happy or anything like that, since pizza is delicious and has lots of chemicals in it that make us feel good. But hearing the word pizza is not the same as eating pizza. So eating pizza could be seen as the conditioned stimulus. But the word pizza, hearing it, is a higher order conditioned stimuli. There has been research done looking at how kind of mundane or basic, how simple these word pairings can occur from, or these associations can occur from. One experiment paired either positive or negative words like happy and sad with nonsense syllables, or syllables that don't have a meaning. So participants would see this list of nonsense syllables at the same time or shortly before they would see or hear a positive or negative word. And what these researchers found was that the syllables that were associated with pleasant words became pleasant, meaning that after conditioning, seeing this nonsense syllable made a person or the participant experience pleasure. The same was true for negative words. And this teaches us that we don't really necessarily have to have meaning with something or for something prior to becoming conditioned to it. We'll look a little bit later about variables that impact how easily it is to condition something or for something to become a conditioned stimulus. And one of those variables is experience, having a prior association with something. We'll talk about that a little bit later. So higher order conditioning, very interesting. As I said, there's no limit to the number of higher order conditioned stimuli you can have, but we do know that the further away from the original conditioned stimulus, the weaker that response is likely to be. So if you start with CS1, maybe think about that pizza example again, and over time you build up to CS30. A 30th stimuli you've learned to associate with pizza. That stimuli likely will not elicit as strong of a conditioned response as the CS1. We also know that it can become very difficult to measure the course of conditioning as higher order variables appear. And that's just because, especially in real life, it is very difficult to control for noise, to control for outside variables. There can be many things happening, many associations that we already have. So the farther we get from the original conditioned stimuli, the murkier it can be. There's a few other aspects of classical conditioning that are important for us to know as well. And these aspects apply to regular classical conditioning as well as higher order classical conditioning. To start, there's this concept called pseudo-conditioning that I want you to be familiar with. Pseudo-conditioning is the tendency of a neutral stimulus to elicit a conditioned response after a single unconditioned stimulus has elicited that same response. So to simplify that, you can think of pseudo-conditioning as a one-time exposure. After one pairing, the conditioned stimuli elicits a conditioned response. For example, if a nurse coughs while giving you a painful injection, you're going to wince. If the nurse coughs again afterwards, you might wince again. And this only took one exposure. While this does follow the same principles of classical conditioning, it doesn't necessarily mean that conditioning has occurred. Very likely, a one-time exposure will only cause a very temporary association between the neutral stimulus and the unconditioned stimulus. So while it might seem as though conditioning has happened, it's not going to last, and it's not necessarily going to follow the same principles of conditioning. That being said, there are 4 basic methods or ways of pairing a stimuli in terms of when the neutral stimulus and when the unconditioned stimuli are presented into the environment. The first one is called trace conditioning, and this is when the conditioned stimulus begins and ends before the unconditioned stimulus appears. So for example, lightning happens, and then a few seconds later, we hear thunder. That would be trace conditioning, with thunder being the unconditioned stimulus and lightning being the conditioned stimulus. A dog growls and then it bites you. Over time, you learn to associate that growl with being bitten by a dog or the potential to be bitten by a dog. Thinking back to the Pavlov example, the metronome went off, and as soon as the metronome ended, the dog was presented with food. Trace conditioning and delay conditioning are the most effective schedules for this type of conditioning. Delay conditioning refers to the unconditional stimulus appearing before the conditioned stimuli disappears. For example, you hear a buzzing for a second, and then while that buzzing is still going on, a bee stings you. You'll learn to associate the buzzing with the sting of a bee. I want you to make sure you are not getting the conditioned and unconditioned stimuli confused here. People have a tendency to think that the unconditioned stimulus always appears first, and that is not the case. With trace conditioning and delayed conditioning, the conditioned stimuli both appear first before the unconditioned stimuli, and that's actually the most effective method of conditioning. There are 2 alternative methods of conditioning, the first one being simultaneous conditioning, when the conditioned and unconditioned stimuli are presented at the exact same time. And this is not very effective, likely because it's not as easy to process both stimuli at the same time if there's no gap between them or overlap. Backwards conditioning is when the conditioned stimuli actually follows the unconditioned stimuli, and this is also not very effective. So we know that the best method of conditioning is to present the conditioned stimuli first, and then either after it's gone away or while it's still going, present the unconditioned stimuli. And this is just a visual representation of that. You can pause the video now and kind of walk yourself through this diagram and look at the visual depictions of the different conditioning approaches. Sometimes having a visual like this or even a kind of flow chart like this can help students understand this concept a lot better. So pause, look over it, and of course feel free to email me if you have any questions. The next variable that heavily impacts classical conditioning is the idea of contingency, and this is very important. Conditioned stimuli, unconditioned stimuli contingency means that when one happens, the other happens. And we know that conditioning works best when the conditioned stimuli is always paired with the unconditioned stimuli. Every time the CS is presented, the US is going to occur. It's easier to create a high degree of contingency like this in a lab experiment. It's not necessarily as easy to do this in the real world. Because of that fact, associations don't necessarily form as quickly or as strong as they do in real life than they do in research. The important point here is that a lack of contingency, meaning that sometimes that conditioned stimuli is presented without the unconditioned stimuli, or the other way around, when we have that lack of contingency between those variables, learning becomes very difficult. So, take a second, think back to the experiment or that conditioning method I had you think about in the first video, where I asked you to come up with a plan on how to stop someone's behavior. And consider the role that contingency needs to play in that. It's going to be very important that your variables always are presented together in order for learning to occur. Another variable that impacts how effective conditioning is this idea of the inner stimulus interval. And that's just the amount of time that passes between the conditioned and unconditioned stimuli. One is presented, some period of time passes, and then the other is presented. And we know that the shorter the inner stimulus interval is, the more quickly conditioning occurs. Researchers think that the kind of optimum ISI for many conditioning examples is around 20 seconds. Stimulus features are also important. Think about the characteristics of that conditioned stimuli. We know that conditioned stimuli can consist of two or more stimuli presented at the same time. That's called compound stimuli. So if during conditioning the black box and the metronome were presented at the same time, it's actually possible for them both to become conditioned stimuli. If, for say, the dog was presented with one or the other individually after the conditioning period. However, when that happens, overshadowing can occur. And this is when one stimuli kind of takes over the effect of the other almost completely, to the point that only one of those stimuli becomes effective or remains effective. Usually when overshadowing happens, it's because one of the stimuli is a lot more powerful than the other. So imagine you were trying to be conditioned with a really strong smell, something like peppermint, and then at the same time, using a compound stimuli, there was a whispering sound. It's possible that the smell of peppermint is so strong that your brain doesn't necessarily process the presence of that whispering sound. Overshadowing occurs, and the peppermint smell is the only conditioned stimuli that ends up evoking that response later on. Then we have stimuli intensity, and this just refers to how strong a stimulus is. We know that the stronger the stimuli, the better results, the quicker learning happens, and the more stable it is over time. However, if a stimuli is too strong, it can become ineffective. For example, if you have an extremely loud noise that is so loud it leaves your ears ringing, you might not necessarily notice the unconditioned stimuli popping into the environment afterwards, and then learning can't occur. Next, we have innate or instinctual qualities. Sometimes the variables that we are conditioned to associate with things are inherently more capable of becoming conditioned. They're things that our brains are just more likely to latch onto. For example, a picture of a snake or a spider tend to be very strong conditioned stimuli. Because of the way our brains are hardwired, we just learn those quicker. Another variable that is important that I mentioned earlier in this video is prior experience with the conditioned and unconditioned stimuli. There's a phenomenon that can occur called latent inhibition, where the appearance of a stimuli without the unconditioned stimuli interferes with the ability of that stimuli to become a conditioned stimuli later. That's a bit complex. Basically, this means that if you are used to seeing the unconditioned stimuli without the conditioned stimuli, it can be very difficult to develop an association with that, and that's called latent inhibition. We know that novel stimuli, or stimuli that we do not have a prior association with, tend to become conditioned easier. They make better conditional stimuli because, again, there's not as much noise there. We don't already have associations with it, so we learn it. We learn that association quicker. When we experience latent inhibition, we can experience something called blocking, which is similar to overshadowing, where a variable does not become conditioned. However, while overshadowing is due to one stimuli being too powerful, blocking happens because of prior experience with a variable. So when prior experience with a variable prevents it from becoming a conditioned stimuli, that's called blocking. Next, we have something called the intertrial interval. Interstimulus interval refers to the gap between the conditioned and unconditioned stimuli. But, as we learned when we talked about pseudo-conditioning, conditioning doesn't just happen after one exposure period. We have to do it over and over again, and the time between those trials is referred to as the intertrial interval. We know that longer intervals tend to be more effective, but by longer, we mean around 20 seconds. However, the intertrial interval can be much longer than that. It can be days. 20 seconds tends to be kind of the happy medium or the happy middle ground. So in the Pavlov example, he played the metronome and then presented the food. Waited 20 seconds, played the metronome again, presented the food. That's the intertrial interval. A few other variables that can impact how quickly learning occurs: age. We know that some conditioning might not necessarily be as effective in older subjects. This can be for numerous reasons. It can be caused by decline in cognitive ability, or it could just be the greater amount of experience, because like we talked about earlier, we know that experience plays a role. Temperament or personality can be important. We know that animals that are more excitable, more hyper, actually tend to learn faster. Stress can also play a role. If there's more stress in the environment, we know that the effect of that stress can actually facilitate classical conditioning or make it easier for that to happen. Interestingly enough, research has shown that the impact of stress varies by gender, but we know that stress can, on average, allow for easier classical conditioning. The takeaway point here, and one thing I want you to make sure you remember, is that once that conditioned response is established, we've had a lot of trials with the appropriate intertrial intervals, interstimuli intervals, and all of these other variables have been met and learning has occurred. Once that conditioned response is well established, it tends to last a long time. So in the next video, we'll actually talk about how we can get rid of that association.